I will also open PowerPoint where I have very minimal set of slides. Okay, Clojure is kind of a Lisp cool language, a weird language because it's old and good. You know, these old languages like Fortran are bad. Code as data, simple syntax, and focused on functional programming, which I'm using here as well, and having good data structures, list, vectors, and maps. Immutable data structures, meaning that you create them and do not modify. And then for mutable state, use a thing called software transactional memory, which I will show here as well. I will not go to the details of Clojure here. You can read more about it from the web. And Clojure has three main implementations. The original implementation is a Java implementation on top of the Java virtual machine. And then we have this Clojure CLR that has integration to the .NET platform. And then there's also the Clojure script that compiles to JavaScript for web pages. So this Clojure CLR, and my experience is that the stability and level of features here is quite good. Although of course this is always, lagging, a few months behind the Java version.
Not more than that.
You think so?
Yes, I said not more than that. It was a question.
Well, when I'm looking at I'm looking occasionally the repository, of this Clojure CLR, and there's weekly commits. So it's there's lots of activity. Most of the activity, states like, implementing this and this, thing from the Java Clojure. So it looks they are following quite well. And the good thing about Clojure is that most parts of the Clojure are implemented with Clojure itself. So many features of the language, a bit like in Ruby, many features of the language are implemented with this language itself, which means they are directly usable in all implementations. The core implementation is quite small. Okay, I will start meanwhile this ChineseWriter program I will use for the demo. I started in the debugging mode from here from Visual Studio. So this is for writing Chinese for people who can speak Chinese but who don't know about these Hanzi characters. So the complex Chinese characters but they are called Hanzi. And then there's another way of writing Chinese, which is called the pinyin, and that's the phonetic writing. So if you see some Chinese names in some newspaper articles like Mao Zedong written with Western characters, that's called pinyin. So that's the way of writing Chinese with these Western characters. And that's actually the way everybody in China even writes Chinese nowadays, because there's no keyboards with the Hanzi characters. So you write the pinyin, and then you use some software to convert the pinyin to the Hanzi. If you specify Chinese input style to Windows, you will do the same thing. You will write the pinyin, and then you will get the small list. When you write some pinyin, you will get the list of the Hanzi characters that match to this pinyin, and there's always multiple possible matches. And then you must select from this list, okay, this is the Hanzi I mean. So you need to recognize the Hanzi characters if you do that. And this is otherwise similar. Here you also write pinyin, and you get the list of the Hanzi, but you also get the English meaning of those Hanzi characters. So let's look how it works. So I can let's write today is beautiful weather. So today I know it is said Jin Tian. I don't remember how the characters look like, but I can write here Jin Tian with pinyin, and it gives me a list of all matching possibilities. And the first one, Jin Tian, is these characters, and I can see, oh, that was the thing today. I can select the first, the top hit. It tries to sort these matches according to the relevance of these matches. So, for example, if I have been marking some words that this is a very well-known word, then it is sorting those to the top of the list. And I can always select the top match, which is 90% of the cases, the first match is the one I want. I just press enter and I get here those words selected. Jin Tian, weather I know it's Tianqi. So I write Tianqi, and again there's very many matches, Tianqi, Tianqiao, Tianjia, Tianqiu, Tianqi, different. Some of them have the same pronunciation, but different characters. Some of them have different tones, but otherwise same. But again, we have the top match here, Tianqi, and then beautiful is Piao Liang. So I write Piao Liang, and I get this. I can also get more information if I want to. Many of these words, some Chinese words consist of one character, but many are like the Finnish combination words. They consist of two, small words combined together. So if you look, for example, it's Jin Tian or Tianqi, I click on this, I get the breakdown of this word. Tianqi is combination of Tian, which means day, and Qi, which means very many things. Gas, air, smell, weather, to make angry, to annoy, with vital energy. Many possible meanings. But these characters together mean weather. Then for this program to be useful, I need to be very easily copy this. So when I'm, chatting with somebody, or if I'm writing some email or something like that, I can take Open Office, for example, here. And then I press Ctrl-C, Alt-C, it says copied, and then I have the Hanzi characters here. And I can go on with this, and then I can also, if I'm reading Chinese, I can select some Hanzi characters, copy them, and click here, paste Chinese, and it will paste the characters here, and it will parse them to the words. So one challenge in Chinese is that when you read Chinese, these are always written together, all in one block. So it's already a challenge to find out which of these characters form the words. And again, this is one feature of the software. It is using the dictionary to find the blocks of words from here. And it has a multi-line layout, so I can write long things here and then copy them all in one go. I didn't copy now. Okay, I get all these things. Okay, let's look at the technology now. So originally I did this with XAML, WPF, and C#. And in the C# I tried to use this functional link library as much as possible, and it was fine. And I thought, oh, this is so elegant. But then I decided later I will do the application logic part using Clojure CLR to learn more about Clojure and to learn more about the interoperability between Clojure and C#. And many of these expressions became even much smaller, with this. And this is open source, so you can find the project from GitHub, and you can find the history and commits from here, and download the code if you want. Okay, I've been showing the UI a bit. Let's see if those still major parts. So basically, you have the cursor. Cursor you can move around here between these characters, and the new input will come to the location of your cursor. If you want to select some other, I can clear this. If I want to select some other match, I write 4, for example, and I can then, the enter was selecting the first match, then I can use Control 5, to select some lower matches, and then I can also click here on any to select any word from the list. And this dictionary has 105,000 words. It's based on a public domain Chinese English dictionary, and if I don't write anything here, then it's just listing all the words of the dictionary in the default sorting order. It's limiting the suggestions to 5,000 suggestions, so it doesn't make sense to have any more than that. But if I put just something like O, then I can see there's 146 possibilities starting with O. So that's defined by myself. So as I use this software and learn Chinese, I'm defining different characters and different words to have different level, how well I know them from 1 to 4, 4 being the best level, and then 3, 2, and 1. And this has 2 uses. I can then track which words I know, and I can also use this to sort the words so that the suggestions that are most common, that I know the best, that I'm more likely to search come first. So then there was the copying of things, and then if I want to, this should be only used as a last resort. But if I really, I'm writing some sentence, and I really don't remember, some word, I can also search a dictionary for English, matches. So I can write here, helicopter, and I find helicopter gunship, from this, and then I can, take this. But often, when searching with English, Chinese is a very, flexible language, so there can be 10 or 20 different words. I chose the word helicopter because that's very specific and technical. But if I take a word like weather or person or something like that, there's usually 20 different matches, 18 of which are some archaic weird variants. So this I use only as a last resort. If I do this, I will usually end up with words that are not very commonly used. So it's better for me to learn the words from some, courses and then just use them here. So here's the breakdown of the helicopter. It comes from the words straight to Askend machine, So very pictographic. Okay, I think that, and then the last feature. So I was usually I'm copying this in the Hansi characters, but I have the possibilities of also copying together the Hansi and the Pinyin, and then I have possibilities to copy together as HTML with English. So let's try helicopter. Sure. So helicopters are interesting. That's what we have written. And now we are copying as HTML. So to copy them in this kind of graphical format as an HTML syntax, which I can then paste to any destination that supports HTML. And now we have to be writing the English only under this. You can see the English is only here, and that's because for those characters and words that I have the known level 2 or more, I'm not putting the English here anymore because I recognize the Pinyin from here already. Okay, that covers the features, and now let's look at the implementation. First, let's look at a small standalone Clojure script which relates to this dictionary. So I'm using CCDict, which is an open source dictionary. And it looks like this. CCDict, community maintained free Chinese English dictionary. It has 1,500 lines, one word per line. And it has a certain specific syntax. There's the simplified Chinese, traditional Chinese. Then there's the pinyin characters written, with this kind of tone marks. So each pinyin can have a certain tone from 1 to 5, and they can be written with numbers after the tone. Now here you can see the tone marks as accents. So this is another way to mark. So these are called accents or diacritical symbols. And so there's two alternative ways to write the tones, with the numbers or with this. And I'm converting in this software from this syntax to this more visually better syntax. I'm also using colors to distinguish between different tones. So the first tone, the high tone, is red. Then the second tone is yellow and has this ascending mark. The third tone has this kind of U mark and is green. And the fourth tone has descending mark and is blue. And the fifth tone, the neutral tone, is black. So four tones plus neutral tone. And the colors can help to remember the tones, because for Western people, remembering which tones to use can be tricky. So I need to read the syntax of this file, and you can see that this file can be easily parsed with regular expressions. Each line can be parsed with a regular expression, but because there's 105,000 lines, it will take some time. It takes about 30 seconds, to parse all of these with regular expressions. So what I do, I have and because this data changes very rarely, I don't need to parse this with the regular expression every time. So I made a small Clojure script called convert CCDict, which is reading this file. It has a regular expression in the Clojure syntax. With Clojure, you use this kind of hash mark to define a regular expression, the literal value, and then it is parsing each of these lines and then writing the lines in the Clojure map syntax. So it is writing a file that uses Clojure's own syntax, which is extremely fast to read then on the next time. This is a standalone Clojure command line, so it is using this kind of special global variable called command line args. So then this can be used from command line, and it will take the parameters, the file to read and the file to write. I will not focus very much on this. It is not so interesting. But it's interesting as an example, perhaps, how to use Clojure as a command line script that reads and writes files, because it's very powerful for that kind of purpose as well. Reading and writing a file, is a very functional thing to do, It's having input, no interaction, no state, producing output. So the main directory here is ChineseWriter. This has the C# code, and then here I have a subfolder called Clojure that has the Clojure files. And here I have a script called convert, and you can see here how this is being used. So I use Clojure CLR, convert CCDict CLR, and then the input file and the output file as command line parameters here. So Clojure CLR starts Clojure main exe, which is the main file of this Clojure CLR, and this has possibility to do interactive closure here. Now, light table, I think we have been looking at light table a bit before. This has also possibilities to evaluate expressions directly inside this editor. On the first execution, it is loading the Clojure framework. But now you can see I can write expressions and evaluate them by pressing Ctrl Enter directly here in the editor, which can be useful. I can define functions and use the functions directly here interactively. But I still sometimes use this prompt, for simple testing. So this is this conversion script, and from this file, it produces CE_DICT_TS_CLJ. That's here. So it has the same data, but it is a Clojure vector. This kind of bracket here starts a vector, and then each item in the vector is a Clojure map, and each map item is keyed by a Clojure keyword. Keywords start with colon, and then the value of that item. So there's the Hanyu characters, there's the Pinyin, and then there's the English. Those are the main things. And here I also produce item called short English, which is like from the long English description, it's the first part before first comma, which I use for the short descriptions of the words. Okay. And then how to use Clojure CLR from C#. First thing to do is you need to define Clojure load path environment variable. This corresponds in the Java Clojure. You need to define the Java class path to include the relevant Clojure directories, and that, of course, we don't have class path in CLR, but the corresponding thing to define is Clojure load path. And in my case, let's start this Rapid Environment Editor. So the main thing to have there is the path to your Clojure CLR directory. That needs to be in this Clojure load path, or things will not work. In addition, if you have some other directories for shared, libraries, for example, I have GitHub Clojure Common, where I have been developing some simple helper functions that I use across multiple different Clojure projects. So then I have been defining them in a common project, and then I need to have that in my load path so that they would be found.
Is this Clojure Common your own project, or do you mean Clojure Common as in?
It's my own. So all the Clojure's own stuff is here in the Clojure CLR, but this is my own.
Yeah, I just thought, did you mean that you're contributing to their library?
I'm not. That's of course a possibility. I don't know what process would. There are indeed some community, libraries for Clojure, which.
You can make a pull request and explain why you want.
That's true. That's true. Yep. So that needs to be done. Then, in addition, it's important to have the load path should also include this your own. So this main folder here. Now that I have not been doing in a very elegant way. I have plans to do it in a more elegant way, but at the moment when I'm starting the program, let's make this a bit smaller. I am simply at the moment having this path hard-coded. So at the start of my program, I'm taking the current environment value of the Clojure load path, and I'm appending this here. This could be easily changed to be relative, to the exe directory, which I will do at some point. And then I am setting the environment variable back to include this way. So after this, then the Clojure load path includes all the directories of any Clojure code that will be used in this program, and also the DLLs of the Clojure CLR. Okay, what's the next step in this project? I also need to add references. I need to add references to the Clojure DLL and Clojure core DLL. These are only DLLs I need to refer here, at compile time. All the other Clojure DLLs and all the other Clojure code that is needed will be loaded at runtime, as when this Clojure load path has been defined. And the main Clojure class for this interop is called Clojure.lang.rt, and that's coming from this Clojure or Clojure core. That's coming from the Clojure.dll. From the Clojure core DLL is coming some of the main types of Clojure CLR. But this RT is the main thing, and this is used extensively for many purposes. So after I have been having the environment path correctly, the load path correctly, having these references, taking the RT, which is short for runtime. So this is the Clojure runtime, taking this into use. Then during my program startup, I need to load my Clojure code. And that's done with RT load. So RT load takes as a parameter a namespace, a Clojure namespace, which must correct to a Clojure source file. So this writing state, for example, is over here, and you can see that corresponds to the name of the file in the load path, that must be in the load path, and it also corresponds to a namespace inside that file. And it is a good idea, and there will be trouble if this file name and the namespace name, they should correspond to each other. I'm not sure if it's an error or if it's just a problem, if they do not, but keep them corresponding to each other. So this RT load loads this file, and of course this file then can load other files via use or require statements. And after this RT load, all the functions and symbols inside this file, it's right there, will be available. And there are some performance problems in the startup of Clojure CLR that are not so bad in the Clojure in the other versions. You didn't see it now, but when I start this program, the window comes up very quickly. But then, for about 10 seconds after that, the title says starting Clojure runtime. So on the first time you are loading any of these libraries, it is loading actually quite many of the Clojure CLR DLLs. And for some reason that takes several seconds. That's quite slow. So I have been putting it to a background thread. So in the window loaded event, I put the thread pool IQ a user work item, which is then loading all this Clojure data. So if originally I was having these just directly in my window loaded event, but then the window doesn't display yet. So that means I had, or even if it displays, it's not responsive. So there was 10-second delay, after starting the program before the window was shown, which, can be confusing. So although one cannot start writing with this program until the runtime is loaded, I think it's better that the window is displayed and it's responsive, and it says, loading there, which can be done with this background.
Do you know whether, when you say threadful queue user work item, does it the same threadful as if you an action tell that begin invoke? Threadful in the background.
If you use dispatcher begin invoke, is that what you?
No, action.
Action begin invoke. I'm not sure about these actions.
Okay. Well,
yeah. I have been. We have been looking earlier here in Helsinki about this new task framework of the .NET 4.0 and later versions, and it would be possible probably here to use the task framework. Now I'm using quite much multi-threading here in other parts as well. For example, here I have been willing to make this program very responsive, and when I press some letter here, you can see the searching dictionary there, and it found 3,700 suggestions, and that took about 5 seconds. And 5 seconds is a long time, and I want to keep this program very responsive. So when it's searching the dictionary, the program is all the time absolutely responsive. All the searching of the dictionary is always done in a background task, and it's never blocking any input, never blocking anything. And when it's searching the dictionary and I press another key, it will abort, the previous search and start a new search. And that is done here. Let's look at that. So threading I'm using here is another interesting topic, and because Clojure, the Clojure logic in the background is completely functional and completely thread safe, it's very easy to use threads here on higher level. So I have here update suggestions background. So this is a routine that is called from a background thread, and that is responsible when there's a new pingin input coming from here. It clears this table and starts to update this table with new set of suggestions. And here I have been writing as a comment to do use .NET task framework for this question mark. So here I'm just using a background worker thread from the thread pool, but it would be more elegant and there would be less plumbing if I would use the .NET task framework, because that supports, for example, aborting execution of threads. And here it's very important that when I'm doing some of the task and then I'm starting a new one, I want to abort the previous one. And now when I'm doing it with my own code, I'm just using threads, then I need to have my own plumbing for, working on this abortion. Let's look at that, because that might be slightly interesting. So when we come into this update suggestion background, it might be that there's some other threads already, working here. So because of that, I have this field called I have this index current updater, which is the sequence number of the update task that is incrementing all the time through the program. So every time a new updater starts, I'm incrementing this, and this is like a unique ID for this specific updater task that's starting here. I use the word task, but let's say thread. And then I set ID, which is the ID of this newly started updater thread. And then there's another variable which is active updater, which is the number of threads that is working here simultaneously. And of course, we would want only one to be here simultaneously. But when we start a new updater, there might be an old one still running. So this might be 2. I don't know if it can ever be 3, but at least it can be 2. So then I have this main updating loop, and in the beginning of the loop, if the number of active updater is bigger than 1, it means we have two threads trying to do this update at a time, and then we should be careful. We should not go ahead when this is the situation. We should wait until the previous updater has been aborting itself. So we wait, and we wait until the ID of this updater is the same as the current updater. Sorry. We wait until the number of active updaters is 1. Then we know we are the one and only. But we return if the ID of this updater is not the current updater, which is and we have here also the same kind of check. So this is the main loop where we are looping through the suggestions. The suggestions are coming from the Clojure backend. We will look at that later. We are looping through the suggestions, and for each suggestion, we are dispatching UI in the UI thread. Of course, when we add an item to this table, that's a GUI operation, and that needs to be done in the GUI thread. So from this loop, so from this loop that is going in the background, adding each line to the table, we need to dispatch as an action in the UI thread. So. I don't have a clear answer. Begin invoke could be used as well. Now the payload here is extremely simple. So we will spend most of the time, doing this adding, and what we do here is extremely simple. So from performance point of view, invoke does not have a worse performance. The fact that we wait here for this to complete, doesn't have a significant performance hit. So perhaps, in those cases where the performance difference is absent, then I might tend to use invoke. For the imagined safety it might add. But, here I think both would be fine. And then here we have this important check. So we are all the time when the thread is doing this action thing, if the ID, if the ID of this updater is not anymore the current, it means there's a new updater waiting to come, and then we should immediately return. And when we return, the number of active updaters will go down, and that will be a signal for the next updater that, okay, the previous one has been going away, let's go forward.
So are these variables shared between threads?
Yes, they are.
Let's say.
Yes. Yeah, so for example, I'm here having this active updaters minus. So it is, and then somewhere I was having active updaters plus. So it could be possible theoretically that these operations would happen at the same time and they would, be in conflict with each other. That's true. There was, until you were using some, there was some method here to use this kind of.
in .NET it's called, I think it's something like, it's in system threading.
Yeah, because in our interlock, and this is used in our WPF VO for checking the core access. This interlocked thing is being used. I will make a note to use that. I think it's something like set interlocked or something like that. Yeah. But in any case, I think, some of the plumbing I'm doing here, like the abortion stuff, could be more neatly done by using the task framework. Then I would need to use less of these, state variables here, which would, perhaps take care of the problem. Okay, but anyway, that means that even though searching the whole 100,000 item dictionary can be slow, it doesn't matter because it will be done in the background. And the other reason why it doesn't matter is that in 99% of the cases, we are interested in the first hits because the dictionary is already sorted. Sorted in the order of interest, which means the words we know and the words that are common will be in the top of the dictionary. So when we retrieve the matching suggestion from the dictionary, it is very likely that we will get in a fraction of a second, the ones that are interesting, and very rarely we need to scroll down, to find some more rare one. Okay, that was the updating, and then let's look at calling functions. So after the rt.load, we want to call functions, and the functions are defined here, and let's take examples from Word database. So Word database has functions for storing this word dictionary and making searches from this word dictionary. I have, in fact, two different dictionaries here. The big dictionary is this CEDICTSCLJ, and this was converted from the open source dictionary. Okay. Now I also want to define my own information. For example, these known levels, how well I know. Then sometimes also this short English thing I get, or even the English description, I want to change it a bit, It might not be, the short English might not be very good. I want to change it to something else. So I need to have data that I can define my own. One possibility would be that I would simply make the software to edit the values in this big dictionary. And that would work, but occasionally I want to upgrade this dictionary to newer version. And if I would do that, then I would convert a new version of this dictionary and it would overwrite all the changes I have made. So I don't want that. So because of that, I have my own dictionary called words CLJ, which has the same syntax. It is a list of maps, and the maps have, all these same parameters, pinyin, hanyu. But here I also have the known levels. I can explicitly define some short, and nowadays I can also define Finnish, word for this. And I can define other parameters here. So to this smaller dictionary, this has only about 2,000 entries, not 100,000. Here I can define custom changes and new words and other stuff. And then I can update the other dictionary. And at runtime, when the program starts, these dictionaries are merged. And there's an additional advantage when I start this program to improve the startup time. It will first load only the small dictionary that has my own definitions, and then I can start writing already using the small dictionary, and it will take about 15 seconds more to load the large dictionary and merge these two dictionaries. And I can, during that time, I can already write with the small dictionary. That is done in the Word database. Let's look at this loading thing. Here is the load database. Let's look where this is being called from the C# as an example. I have been using this kind of pattern that when I have a namespace or a module Word database, then I have been usually making a corresponding C# file. So I have here this public static class Word database. And this is mainly having methods that are static methods that are corresponding to those Clojure functions, and makes it a bit easier, makes it a bit nicer the syntax of calling these. Because here you can see how we are calling now this. So to call a Clojure function, we use first rt.var to retrieve the function object. So each function in Clojure is an object, and we retrieve it with rt.var, with the parameters being the namespace and the name of the function. And after it has been retrieved, we can call it with invoke. And then the invoke takes the parameters, which are the file path for the large dictionary and the file path for the small dictionary. So this, is the syntax. And for many of these calls, you can see I have been making these kind of wrapper functions here to make the calls easier. Another reason to make these wrapper functions is that because Clojure is dynamically typed language, it means all the input parameters here will be just objects, object, object, object. And the output, the return value is always just an object. But C# is not a dynamically typed, it's statically typed language. So there's casting required. And then doing these kind of wrapper methods helps me, to cast the input values and the output values, so it will be easier to use. We are running out of time now here, so I will finish by looking at this load database, and then we will stop for here. Here I'm using a Clojure reset function. Here I'm defining things called atoms. Atoms is the way in Clojure to define state or define variables that are changed, a mutable state. So Clojure does support mutable state, but in a very controlled way, and a thread-safe way. So these setting these with reset is a thread-safe thing. So I'm having here all words, which is an atom, and word and then word dictionary and word info dictionary. So this all words is the list of words. It might be in the startup of the program, it will be the short list, and after full startup, it is the list of everything. And then I have two dictionaries here, meaning they are maps. So instead of being just a list of the words, they are maps where I can search for specific words with the Hanyu and the Pinyin as the key. So when I'm loading the words, I am using load from file. I am loading the short words, and then I am making a dictionary or map from the short words. I am setting the file name for later saving, and I am setting the word info dictionary. And then I call set database with these short words. And at this point, the user can start writing already, and it's working. But then I will continue to load the full dictionary. And this is executed in a background thread again, so that everything is responsive. And then here, final beautiful thing. This is something that here's merge with merge. This is very high level functional stuff. So here I'm having two dictionaries. I'm having two maps. Each one is keyed with the Hanyu characters, and it has the word definitions as the values. And what this will do, it will take these two dictionaries and it will merge them together, so that if there's some words that are in this dictionary A, they will come to the result. Some words that are in the B, they will come to the result. And those entries that exist in both dictionaries, it will merge the attributes. So then it will merge the attributes of those entries. So with this very, very concise call here, it will do very complex, powerful things by taking two dictionaries, merging the entries, and inside each entry, merging the attributes.
Merge your own function.
No, these are all, and these are all coming from the Clojure framework. So the Clojure framework provides this very powerful merge with and merge, and combined together, it will do this thing. Okay, we are out of time. Many things were not covered, but you can later ask me if you are interested and look on your own. Any questions from the people on the line? Where's my... Okay, bye-bye.